In the last lecture, we have discussed well ordering principle, divisibility theory, properties of divisibility, division algorithm. In this lecture, we are going to discuss GCD, properties of GCD, Euclidean algorithm for finding GCD. The integer d, which is not equals to 0, is said to be the common divisor of A and B if D divides A and D divides B. That is, if D divides both A and B. We know there is only a finite number of common divisors of A and B. The largest of all common divisors is called the greatest common divisor. We know there is only a finite number of common divisors of A and B. The largest of all common divisors is called the greatest common divisor. Of A and B, and it is denoted by GCD of A comma B, or simply in the bracket AB. Obviously, GCD of AB is always greater than 1. If GCD of AB equal 1, then A and B are said to be relatively prime or coprime, or they are prime to each other. Example: GCD of 4 and 12 is 4. GCD of 4 and 9 is 1. GCD of 15, 17 is 1. Properties of GCD 1. GCD of AB equal GCD of BA for all A, B belongs to Z, the set of integers. This is called commutative property. Number 2. GCD of AB, C is equal GCD of A, GCD of B, C, where for all A, B, C belongs to Z. This is called associative property. Property number 3. For any positive integer m, GCD of MA, MB equal M GCD of A, B. This is called distributive property. Property number 4. If C divides AB and B, C are coprime, then C divides A. Property number 5. If A and B are coprime and A and C are coprime, then A and BC are coprime. That is, GCD of AB is 1 and GCD of AC is 1. This implies that GCD of A, BC is 1. Property number 6. If D divides A and D divides B, where D greater than 0, then GCD of A by D, B by D equal 1 by D GCD of A, B. Property number 7. If GCD of A, B is 1, then for any integer x, GCD of Ax, B equal GCD of x, B. Property number 8. If A1, A2 to AN are relatively prime, to B, then their product A1 into A2 into up to AN is also prime to B. GCD of A1 into A2 into A3 up to AN, B equals to 1. Euclidean algorithm for finding GCD. Here is one theorem. Let A and B very greater than B be any two integers if R1 is the remainder when A is divided by B. R2 is the remainder when B is divided by R1. R3 is the remainder when R1 is divided by R2, and so on. If Rp plus 1 equals to 0, then the last non-zero remainder Rp is the GCD of A, B.
For admission and course-related enquiry, please visit college website http://www.svist.org/